This video we're going to look at erosion control. So the first step of that erosion and sediment control process is to minimize erosion. As I mentioned, the minute you take off topsoil or vegetation off land, the rain has direct route to it, it's going to cause erosion. You can get raindrops sort of hitting the soil, dislodging particles. The runoff is going to run along unprotected land. It's going to cause more erosion with its velocity. And so erosion control is designed to try to minimize that as much as possible. You won't stop erosion, but you will minimize it. It's section E of GDO5. You recall that that is the guidelines used in Auckland for erosion and sediment control systems. We've got a copy on Moodle if you're doing this course. If you're not doing this course, you can go to the Auckland Council website and you'll find GDO5 as a free download. It's a very good document. So you can see this little chart here. Erosion control consists of two things. So managing the control flows. So the diversion channels, that sort of business, and then stabilizing the surfaces. So the process is to try to manage the flow, manage erosion, try to prevent it happening, and then try to get your surfaces stabilized as quickly as possible. So let's look at some of those steps there. So we're going to look at each one of these. Reduce the overland flow to the site, which is called run on. So you've got run off, which is running off the site, which is carrying sediment laden sediment with it. You've got clean water. It might be there's a vegetated site upstream from your site and water's flowing onto that. Now the minute that water flows onto your site, it's going to become contaminated with the soil and it becomes your problem. But if you can prevent it from becoming your problem, prevent it from running onto your site, then that is just one less problem for you. So you can see here, this is an unvegetated, undisturbed vegetated area, and there's the work site. So any water that falls on here or flows onto here is your problem, and you have to, it'll determine the size of the silt ponds, the amount of work you have to do. Now this water that's flowing over here is flown across, it's flowed across vegetated ground. It's not contaminated. So if you can divert it around the site and then to a natural water course, you don't have to do any treatment or anything like that. It's still clean water. The minute it gets onto the site, it's your problem. So what we normally do is we create a little bund around the perimeter of the site. So here's some earthworks here, and you can see what they've done is they've turfed all of this, they've dug up this, and they've made a little mound. And so the water from this vegetated area is going to flow here, and it's going to flow along the ground and then around the site. You don't have to worry about that anymore. So that is called a clean water diversion drain, and you really want them around the perimeter of your site on the uphill side. So where there's an uphill, where there's a boundary with vegetated area, you want to put a barrier between it, and that's what a clean water diversion drain is. And obviously it's got to flow to a natural water course. It can't just sit there and pond. So it lessens the amount of dirty water produced, and it lessens the volume of dirty water that you have to treat. And the next approach is on your site is to minimize the flow velocities on the slopes. So everyone's sort of had a go-kart or a skateboard or something like that, and you start at the top of the hill, and when you're going down the hill you're going slowly, and then you build up speed and you build up speed and you build up speed, and if you hit something at the bottom of the hill, it's going to be much worse than if you hit it at the top, because you're going faster. You've developed more energy. So as water's flowing, and so it's the same with water, as it's flowing downhill, it builds up energy. It builds up the ability to cause erosion. So if you can keep the flow velocities down, then there's going to be less erosive force, and there's going to be less soil erosion happening. And so there's several ways you can do this. The first one is benching. So there's the flow going down there. So it's building up speed, and then it hits this bench, and it stops, and it's connected into a channel which goes to a drop structure. We'll look at those in a minute. And so what you're doing is you're minimizing the length of flow. Now if you didn't have the bench there, then the water would be flowing straight down, and it developed a lot of velocity and a lot of erosive power by the time it got to the bottom. So what we're doing there is we're just lessening the amount of flow, the distance it flows, and therefore the velocity it does. And so once we get it there, then we need to divert it across the site to a drop structure, which will be then drop it down to the level of the silt pond. Another version of this is contour drains. So you dig, so in this case here, what they've done is they've taken, you can dig holes, so you can dig little trenches around around the site, or in this case here, they've used some filter socks. So they've put some filter socks there. It does the same thing, it diverts the flow around to a drop structure. So what you're doing there is you're lessening the flow, the distance the water flows, and then you're diverting it to one of these things, which is a flow structure. So the flume or flow structure is the water all comes here, it concentrates, and so if we just let it flow down the hill, it would cause massive erosion because there's a high volume of water and it's traveling very fast. But we have structures built to take it without causing erosion. So that might be a chute made out of metal or plastic, or it might be a pipe, a drop pipe. Whatever it does, you're sort of taking it from that high level. So the idea of these things is to take the water from a high level and get it down to a low level. So it's going pretty fast, it's like a slide, it'll build up velocity, and then at the outlet you'd have some sort of rocks or something to dissipate it, or sometimes a manhole with holes in it, and so the water comes in and hits the ponded water and slows down that way. So you've got to slow it down as well, so it's not just the pipe, it's also the outlets need to be designed as well. Another way of minimizing the flow velocities in water channels is to once again step it. So here you can see there's a water channel here, and they've put some filter socks in, and so the water flows along and then it hits this water sock and there's a ponding of water here, and that ponded water acts like a bit of a brake for the water, and then it gradually spills over the top there, not going any velocity at all, then it builds up and then it hits the next one and so on. And the same philosophy, so there you can use filter socks. In this case here they're using rock drains as well. So you can use either or. The thing about a rock drain is the water can actually go through it, but it moving through the rocks will cause it to slow down. So once again we're trying to decrease the velocity in the water channel. Decrease the velocity, you decrease the erosive force. Another thing you can do is protect the water channel by lining it so it doesn't erode. So we saw those drop structures which were made out of metal or plastic. You can also line channels with geotextiles, so there's geotextile there, or you can line it with rocks. Once again, that is providing a barrier between the soil and the water flow, and in this case here it's providing a barrier, but it's also causing turbulence, and the turbulence will result in the velocity being reduced as well, although turbulence can cause erosion as well. Another way of preventing erosion or minimizing erosion is to protect the surfaces. So oftentimes you will roll it tight. So if the soil on the surface is loose, then it's going to be more likely that the raindrops can actually knock it, can loosen it and cause erosion. And if it's flowing across, it's going to be more likely to erode. So if you can tighten up the surface by rolling it, then it's going to be more impermeable and the water's just going to flow over the top of it rather than causing erosion. So you can roll it with excavators or bulldozers. Another advantage of rolling it with excavators and bulldozers is that you're surface roughening it. So the cleats actually cause little footprints in there, and they cause the water flow to slow down. It's going across a rough surface, it's hitting the footprints, which is causing turbulence, which is slowing it down. So when you do surface roughening by rolling, just having an excavator or a roller, or a bulldozer, anything with tracks, going up and down and up and down, you tightening up the surface, and you're also putting these marks in there, which is going to slow it all down. Another way of protecting the surface is to reinstate the surface as soon as possible. So you do the earthworks, and then when the earthworks are complete, you don't just leave it open. You either put topsoil down and then plant it in grass. But the trouble with that is the topsoil, until the grass establishes, is not all that protected. So oftentimes you'll have to put the topsoil down, put the grass down, and then put mulch on top. And so mulch is just chopped up bits of vegetation, chopped up trees, bark, can be hay as well, and you put it over the top, and that provides temporary protection. After a time it will actually decompose, but by then the grass will have established and be coming through. So topsoiling and grassing followed by mulching is the most common way of stabilizing a slope afterwards. Another way of doing it is if the slope's too steep, you can do this thing called hydroseeding. And what that guy's got there is he's spraying this mixture of water, paper pulp, and seeds and fertilizer. So what they do is they just take paper, they throw it in water, and as you're aware, when you throw paper in water, it turns into this pulpy mess, and it'll stick to things. And what you do then is you mix the fertilizer and the seeds into the mix as well, and then you spray it on. So what you've got now here is you've got this pulp sticking to the sides of the slope, and it's got the seeds and the fertilizer sitting in it. And so the seeds will germinate and establish, and the pulp will form a structure that will hold it all together until the grass has time to establish. And obviously the fertilizer is there to help it to establish. So those steps there are not all either ors, they are ands. So you put in surface protection, you reinstate the surface as soon as you can. So you do as much as you possibly can. You put as many layers of protection in to minimize erosion as you possibly can. But erosion does happen, which is going to lead us on to our next video. What do we do with the sediment that does get produced from the site?